Hello, this is Algebra 1, Lesson 9.5, Multiplication with the Addition or Subtraction Method. So, in our last video, we learned about the addition or subtraction method, also known as the elimination method. This is just an expansion of that idea. Sometimes the coefficients will not cancel when you're trying to add or subtract two equations, so you're going to have to do an extra step of multiplication at the beginning to make the values cancel out. So we're going to look at several examples. Otherwise, the process is the same as the addition or subtraction process. All right, so first example, if we have 6x plus y equals 6 and 3x plus 2y equals 9. That's our set, or our system. You have options. You can choose which variable you would like to cancel out. Would you like to make the x's cancel out, or would you like to make the y's cancel out? It's totally up to you. It does not affect the ultimate outcome of the problem. You might cancel out the x's and get a y answer first. I might cancel out the y's and get an x answer first. It doesn't matter because we're both going to solve for x and y, so we're both going to get the same answer, even if we take a different way to get there. So I've decided what I want to do is I'm going to focus on the y's. Up here I have a positive 1y. In the second equation I have a positive 2y. If I want those to cancel out using addition, I need this to be a negative 2y. If I can make this a negative 2y, then when I add these two equations together, they'll cancel out. So in order to do that, I'm going to multiply everything in that top equation by negative 2. That looks like x minus 2, so I'm multiplying by negative 2. I like to put the arrow and the little number on top to remind myself what I chose to do, because this is a mistake that's commonly made, is that people will start out multiplying by what they're supposed to multiply by, but then they'll forget what they're doing and they'll get to the end of the problem and they won't multiply all the way through. So 6x times negative 2 is negative 12x. Positive y times negative 2 is negative 2y, and then positive 6 times negative 2 is negative 12. You have to multiply all the way through the whole equation. All right, now I'm not going to have to multiply the second equation by anything on this one. Sometimes you will. Sometimes you're going to have to pick something to multiply on the top and the bottom in order to make something cancel out. But this one we don't have to, so we're just going to bring this one over. 3x plus 2y equals 9. I highly recommend that you rewrite it this way. It's the clearest way for you to see what your work is. It's the least likely that you'll make a mistake. All right, so we're going to add these equations together. Negative 12x plus 3x gives me negative 9x. Negative 2y plus 2y cancels out. And negative 12 plus 9 gives me negative 3. Then I need to solve for x, so I'm going to divide both sides by negative 9. Negative 3 divided by negative 9 is going to be positive. 3 divided by 9 reduces to 1/3. So my first answer is x equals 1/3. Now, I want you to take that back to one of the original equations. It does not matter which one you choose, but go back to one of the originals. Don't go back to one that you changed. Go back to an original. All right, so I'm going to go back to this first one. I'm going to replace the x with my 1/3 that I just figured out. So I have 6 times 1/3 plus y equals 6. 6 times 1/3 gives me 2. Plus y equals 6. Subtract 2, and I get y equals 4. Now, whenever you're solving a system of equations, you must write your answer as an ordered pair. One thing I noticed on the homework that got returned in the last packet is several of you did not write your answers as ordered pairs. That is a requirement, so make sure you write it as an ordered pair in alphabetical order. So X, comma, Y. If you have different letters than X and Y, just go in alphabetical order. All right. Remember, if you want to check your answer, you can plug the 1/3 in place of the X and the 4 in place of the Y and check it in the first equation, but you also must check it in the second equation. It has to be true for both equations to be a true solution to the system. All right, let's try another one. If we have 4a minus 5b equals 3, and 3a plus 2b equals -15. Okay, so again, you are in control. You decide what's going to be canceled. It does not matter. You can choose to cancel out the a's first, or you can choose to cancel out the b's. It does not matter. I'm going to choose for this one to cancel out the a's. So on the top, I'm going to multiply everything in this equation by 3, because I'm going to make both of these 12. Well, actually, I'm going to make this one positive 12. I'm going to make this one negative 12, so that way they'll cancel out. So on the top equation, I'm multiplying everything by 3. So 4a times 3 is 12a. Negative 5b times 3 is negative 15b. And then 3 times 3 is 9. All right, for the second equation, again, I forgot my a. For the second equation, I'm trying to cancel out the a's. The first equation now has a positive 12a, so I want to make this a negative 12a. That's just what I chose to do. So that's what I'm going to follow through with. That means I need to multiply everything down here by a -4. Okay, so 3a times -4 is -12a. 2b times -4 is -8b. And -15 times -4 is positive 60. So now I can add my two equations together. -12a plus 12a cancels. That's what I wanted. I planned that on purpose. -15b minus 8b gives me -23b. And 9 plus 6 gives me 69. All right, then I'm going to divide both sides by -23. Positive 69 divided by -23 gives me -3. Okay, I have one answer. Now I need to go back and get the other answer. Go back to one of the original equations. Again, it does not matter which one you choose, but choose one of the original equations. Do not check your answer in one of your changed equations, because there's more likely to be an error that way. So I'm going to test it in the first equation. 4a minus 5 times -3 equals 3. So I'm replacing the b with my b value of -3. 4a -5 times -3 is positive 15. So 4a plus 15 equals 3. Subtract 15 from both sides. 4a equals -12. Divide by 4. A equals -3. Again, you're not done until you've written your solution as an ordered pair in alphabetical order. This one, they happen to be the same answer, -3, -3. Again, you can check that by putting in -3 for A, -3 for B, and checking the first equation. And then you have to put in -3 for A, -3 for B, and check the second equation. It has to be true in both equations in order to be a true solution. All right, let's try a few more examples together. I want to make sure you get plenty of examples to look back on. And then remember, there's also examples in your book. I try to choose different examples for the videos than what are provided in your book, so that you've got extra examples to look at if you get stuck. All right, for this one, we're going to do 3x over 2 plus y equals 6, and x plus y equals 5. So that's my system. All right, In that first equation, having that 2 in the denominator can really throw people off. So what I want to do first, before I change anything else, I'm going to multiply everything in that equation by 2, because that's going to clear out the denominator in the first term. So 3 halves times 2, the 2's will cancel out, and I'll just have 3. So 3x, but then I have to keep going. So y times 2 gives me 2y, and then 6 times 2 gives me 12. So I multiplied everything in that equation by 2 because I wanted to clear out that fraction, because everybody tends to just do weird stuff if they're trying to work with fractions. All right, so now that I'm working with this equation, I want to make something from this equation cancel out. Again, it does not matter. You can choose to cancel out the x's, or you can choose to cancel out the y's. Either way is fine. I'm going to cancel out the x's. So if I want to cancel out the x's, I have a positive 3x in the first equation. I'd like to make this a negative 3x in the second equation. So I'm going to multiply everything in the second equation by negative 3. So x times negative 3 is negative 3x. Y times negative 3 is negative 3y. And 5 times negative 3 is negative 15. Okay, then I'm going to add my equations together. 3x minus 3x cancels. That was my goal. 2y minus 3y gives me negative y. And 12 minus 15 gives me negative 3. Then I'm going to divide both sides by negative 1, so that positive y equals 3. Once you have your answer for y, you can go back to either of your original equations. I'm going to avoid the equation with the fraction just because, again, I can do that just fine. Some of you will make a mistake just because you're trying to work with a fraction. So if you have a choice that doesn't have a fraction in it, why not use that choice? So we're going to choose this one. So x plus 3 equals 5. Subtract 3 from both sides. X equals 2. Again, you're not finished until you've written this as an ordered pair. 2, 3. Okay. Next one. 4x minus 2y equals 10. 3x minus y equals 12. All right, so you get to choose. Do you want to make the x's cancel out? You've got 4 and 3, so you could go for the 12s again. Or do you want to make the y's cancel out? You've got 2 and 1. If you want to make the y's cancel out, you only have to multiply the second equation by something in order to make this cancel. So I'm going to go with that option. I'm going to keep the first equation exactly the same. No change. Now, for the second equation, I've got negative 2y and negative 1y. I would like for this to be a positive 2y so that it can cancel with that negative 2y. So if I want this to be positive 2, I'm going to have to multiply it by negative 2. So that means everything in the second equation gets multiplied by negative 2. 3x times negative 2 gives me negative 6x. Negative y times negative 2 gives me positive 2y. And 12 times negative 2 gives me negative 24. Okay, now I'm going to add my two equations. 4x minus 6x gives me negative 2x. Negative 2y plus 2y cancels. And then 10 minus 24 gives me negative 14. Divide both sides by negative 2. Negative 14 divided by negative 2 is positive 7. All right, then we're going to go back to either of your original equations. I'll pick the second one. 3x, oops, we're testing that, sorry. We're going to put 7 in place of the x. 3 times 7 minus y equals 12. So 21 minus y equals 12. Subtract 21 from both sides. Negative y equals 12 minus 21, so negative 9. Divide by negative 1. Y equals 9. So my ordered pair, x, y, is going to be 7, 9. All right, last one, just because I want to make sure you've got plenty of examples to look at. If we do this one, 5a plus 3b equals 43. Negative a plus 7b equals negative 1. So that's my system. All right, let's look at our choices. We have a positive 5a and a negative a, a positive 3b and a positive 7b. I can go for the a's and have a positive 5 and a negative 5, or I could go for the b's. I'd have to go for 21s. Because these already have opposite signs, and because I would only have to multiply one equation, I'm going to go with a's. So the first equation is going to stay the same. 5a plus 3b equals 43. I want to cancel out the a's, so I'm going to multiply in the second equation everything by 5. So that's going to be negative 5a plus 35b equals negative 5. Then I can add the two equations together. 5a minus 5a cancels. 3b plus 35b gives me 38b. 43 minus 5 gives me 38. Divide both sides by 38. b equals 1. Then you need to go back to one of your original equations. Doesn't matter which one. I'm going to do the top one. So 5a plus 3 times 1 equals 43. We're replacing that b value of 1 in place of the b. 5a plus 3 equals 43. Subtract your 3. 5a equals 40. Divide by 5. A equals 8. So my final answer, my ordered pair, AB, 8, 1. All right, so that's how you use multiplication with the addition and subtraction method. You've got a lot of freedom here. We might choose different ways to solve the problem, but we will get the same solution. There will only be one solution, and we should match for our answer. Be sure to look through the examples in the book if you'd like to see some more examples of how to work these out. Remember, you can also check your answers by plugging them back into the original equations. If you have any questions, send me an email. During office hours, I'll respond for sure. If you send it not during office hours, that's fine. I just might see it later, and I might not respond until the next time I get online. I hope you guys are doing well, and remember, there's strength in numbers.